Hi students, welcome to today's class. Today we are discussing about different memory characteristics. Okay, so there are 10 characteristics of memory. The first one is location. Okay, location based on its physical location, memory is classified into three. That is on-chip memory, internal memory and external memory. On-chip memory. This memory is present inside the CPU, that is internal registers and L1 latch. Okay, on-chip memory is nothing but which is present inside the CPU. The next, internal memory. This memory is present on the motherboard, that is RAM and ROM. Okay, then the third memory is external memory. This memory is connected to the motherboard. Okay, this is the memory which is externally connected to the motherboard, that is external memory. Example, hard disk and pen drive. Okay, so these are the main memory locations. On-chip memory is nothing but it is the memory which is inside the CPU. Internal memory is the memory present in the motherboard, that is RAM and ROM. External memory is nothing but which is connected external to the motherboard, that is pen drive, hard disk, CD drive, etc. Then the second memory characteristics is nothing but storage capacity. This indicates the amount of data stored in the memory. Okay, from the name itself it is clear that what is storage capacity? It indicates the amount of data that is stored in the memory. This is represented as N by M. Okay, N into M or N by M. That is, a memory can be expressed as N by M. So what is N and what is M? N is nothing but number of memory locations, that is number of words. So N is number of memory locations and capital M is number of, this is not bits, bits, number of bits per memory locations. Okay, so N by M, all the memory capacity or the storage capacity is represented as N by M. So N is nothing but it is the number of memory locations and M is the number of bits per memory locations. Okay, so how many bits are included in that location. So example, storage capacity is normally represented as 4K by 8. 4K by 8 is nothing but which means that there are 4K locations and each location of 8 bits size. Okay, that is storage capacity. Then the third memory characteristics is transfer mode. Data can be accessed from the memory in two different ways. Okay, so data can be accessed for different purpose and from the memory. So data can access the memory or transfer the data from the memory in different modes. First mode is word transfer. Here CPU needs some data, it will transfer only that amount of data access from the L1 cache. Actually, what is word transfer? Word transfer is nothing but it transfer only the required amount of data. If we are requesting some data to the memory, then memory provide that requested data only to the cache. Okay, or from the cache to the CPU. Okay, so that is called word transfer. It only transfer the required amount of data. Then next, block transfer. Here, if CPU needs some data, it will transfer an entire block containing the data. Here in block transfer, if CPU want any data, but L1 cache or cache memory provide not that particular data, it will provide a block of data. It contains other data too, a required data plus some other data too. Okay, so this makes further access to remaining data of this block much faster. So block transfer is nothing but if CPU want any particular data, then a block of that data is transferred from the cache memory. That is, that block of data contains the required data which is needed for CPU and data other than the required data. So always the CPU can access all the data in that block. This is based on the principle of spatial locality. A processor is most likely to access data near the current location being accessed. When a cache miss, process goes to maintain memory, copies a block containing that data. Okay, if you want to convert the data or if you want to use the data, the CPU can access all the block of data. Okay, not only the required data, the CPU can access all the data which have transferred. That is all the data inside the block. Okay, So that's all about transfer. So we have discussed two type of transfer, word transfer and block transfer. Word transfer is nothing but if CPU requests some data from memory, then the memory provide the requested data only. And block transfer means the memory provide not only the requested data, it provide a block of data which contain the requested data and other data too. Then the fourth memory characteristics is access mode. Memories can allow data to be accessed two different ways. The first one, sequential access, that is memory can be accessed in sequential way and in random access. Here locations are accessed one by one in a sequential manner. The access time depends on how far the target location is from the current location. Farther the location, more will be the access time. That is magnetic tape. Okay, so sequential access is nothing but it accesses the data in a sequential manner. That is, if you want to access the address 1000, it will move from 1 to 3, that is sequentially, and will reach the 1000 address, the data in the address 1000. Okay, so if the address is very far, okay, how far the target location from the current location. Okay, if the target location is very far from the current location, then the access time will be increased because it will access that data sequentially, that is one by one, and it will reach the target data one by one, so that it can take more time. So the access time is more in sequential access since it access one by one sequentially. Okay, so depending upon the distance from the current location and the target location, the access time will be varied. If the target location near to current location, then the access time will be less. If the target location is very far or away from the current location, then the access time will be large. Then random access. Here all the locations can be directly accessed in any random order. This means all the locations have the same access time irrespective of their address. Most modern memories like RAM. Okay, the random access means all the addresses, that is if there are 1 to 1000 address, then all address has same access time. That is if the current location is 20, then the target location is 500. So the access time to 20 to 500, it directly go to 500 address, which means that its access time is equal. So even if the distance between current and target address varies or increases, the access time is same because it can access randomly, not sequentially. If you want to access any particular address, it can access directly to that address. So random access means it uses only a small period of time, or the access time is very less because all locations can be accessed at any order or at random order. So it is called random access. So that's about access mode. Then the fifth memory characteristic is physical properties. There are various physical attributes to memory: writable, non-writable, volatile and non-volatile. That is physical properties of a memory. Writable means it can overwrite. If that memory is nothing but it can change the data, that is writable. Content of the memory can be altered. Okay, that is writable. That is we can write to the memory. Okay, so if you want any change in the data that in the memory, we can make changes. So the content can be changed or can be altered, that is writable property. Example, RAM, random access memory. ROM is read-only memory, it is not writable. Okay, so writable memory is nothing but content of the memory can be altered. Example, RAM. Non-writable memory is nothing but content of the memory cannot be altered, it is fixed. That example is read-only memory, it cannot write. Okay, so the other physical property is volatile. Content of the memory are lost when power is switched off, that is RAM. Non-volatile, content of the memory are retained when power is switched off, that is ROM. So we have already discussed the volatile properties of RAM and non-volatile properties of ROM. If the power is switched off, then the content will be lost, then it is called volatile. Then in non-volatile memory, even if the power is lost or power is switched off, the data in the memory will be retained. It will not lose. That is example ROM. So these are the 4 physical properties of memory. Then next property or next characteristic of memory is access time. It can be written as TA, latency. It's also says as latency, access time. It is the time taken between placing the request and completing the data transfer. It should be less as possible. It is known as latency. So access time should be very less for a process to be continue, or for a successful data processing, the access time should be less. If the CPU requesting some data from the memory and the memory providing or completing the data transfer, it should be, the time between these should be very small, that is access time. So the time between the request and the completion of the data transfer, okay, that is called the access time. So it should be very less. If you request any data from the memory, memory should provide with no time to the CPU. So that is the property of a memory, access time. It should be less. So access time or latency is nothing but the time between requesting a data and completing the data transfer. Then the 7th characteristics is reliability. Reliable. It is the time for which the memory is expected to hold the data without any error. Okay, so it is measured as MTTF, that is mean time to failure. Mean time to failure. It should be as high as possible. Reliability means it should be reliable. The memory should be reliable. The reliability means it should be as high as possible, which means that the memory is expected to hold the data without any errors. So the memory, what are the data saved to the memory should be safe and it should be reliable. That the data in the memory should hold, the data in the memory should, memory should hold the data which is given to memory without any errors. That is reliable. So a memory should be reliable, which means that the memory can hold the data without any errors. This is called reliability. The next one is cost. It indicates the cost of the storing data in the memory. So memory, cost of the memory. It is expressed as cost per bit. Okay, so it must be as low as possible. Okay, so a memory characteristic means cost should be as low as possible. So cost is based on the bit. We already know that if you use a memory card of 64K memory card and if you use 256K memory card, so the size will be varied. Okay, so the cost is expressed in terms of size. If size increases, cost increases. If the memory size decreases, cost decreases. We know that for a hard disk or for any pen drive or for a memory card, we all are calculating the price based on their size. Okay, if it is 1 terabyte, the price will be high. If it is 256 kilobyte, then the cost will be low. And if it is 16 kilobyte, then the cost will be low. So that's why the cost is represented or expressed in terms of bits or cost per bits. According to the size, the cost will vary. Okay, so for the characteristic, memory characteristics, the cost will be less. Okay, then the 9th is average cost. It is the total cost per bit for an entire memory storage. Okay, so average cost is nothing but it is the cost per bit. We already discussed cost is expressed in terms of bit. So average cost is nothing but cost per bit for entire the memory storage. Consider a system having 2 memories, M1 and M2, RAM or ROM. Something like that. So just consider M1 and M2, 2 memories. If C1 is the cost of memory M1 with a size S1 and C2 is the cost of memory M2 with a size S2, then the average cost of the memory can be calculated as average cost is equal to C1S1 plus C2S2 by S1 plus S2. C1 is nothing but cost of memory 1, C2 is nothing but cost of memory 2, S means size of memory 1, S2 means size of memory 2. So cost into size plus cost into size by total size, that is average cost is nothing but C1 S1 plus C2 S2 by S1 plus S2. This is the average cost. Then the last property or last characteristics of memory characteristics is nothing but hit ratio. Hit ratio means capital H. So in order to understand the hit ratio, we have to consider two memories M1 and M2. So M1 is closer to the processor than M2. Okay, so let M1 be RAM and M2 be hard disk, something like that. So first you consider M1 is any memory and M2 is other memory, but M1 is closer to the processor than M2. So there are two memories M1 and M2, but M1 is closer to the processor than M2. M2 is far away from the processor. If the desired data found in M1, then it is called a hit, else it is a miss. So if CPU or processor found the desired data in M1. If processor wants some data, if processor found the desired data in M, then M1, then M1 memory is called a miss. Sorry, a hit, and else it is a miss. So if the processor needs some data, it has two memories M1 and M2. The processor got the data from M1. If the processor got the data from M1, then memory M1 is a hit and memory M2 is a miss. So if any processor requested a data, if the requested data there in the memory M1, then the memory M1 is called hit. If there is no data in memory 1, then it is called a miss. Okay, so let N1 be the number of hit and N2 be the number of misses. Okay, so N1 means number of hit, that is number of data present in the memory, and N2 means there is no data present in the memory which is requested by the CPU. Then N1 means number of hit and N2 means number of miss. Then the hit ratio is defined as number of hits divided by total attempt. So H is equal to N1. N1 means number of hit divided by N1 plus N2, that is total attempt. Okay, that is called hit ratio. It is expressed in percentage. Hit ratio can never be 100%. In most computers, it is maintained around 98%. Okay, so hit ratio can be maintained inside the computer. It is 98%. That is N1 is nothing but hit and N2 is nothing but miss. Hit is nothing but if a processor requests any data, if the data present in the memory, then that is hit. If the data is not present in the memory, then that is miss. Hit ratio H is equal to N1 by N1 plus N2, that is number of hit by total attempts. Okay, so that's all about memory characteristics. There are 10 memory characteristics. Okay, so that's all about today's class. Thank you.